So mental conversion to a certain base. So here are some examples. So we want to convert the number to base 5. Now you should train your mind to do this mentally, but how do we come up with it directly without any calculation? Now that comes with practice, but I'm going to show you how I think about it. So I look for the power of 5 because we are looking at base 5. That is less than 7. You should keep on going all the way up to a number so that it is less than 7. So I could start at 5 raised 0, 5 raised 1, 5 raised 2, 5 raised 3, ... Keep on going. So any number raised to the power of 0 is 1. Next one is 5. So the number that is less than 7 in base 5 is 5. So if I took out 5, I am left with 2. So 5 plus 2 is 7. So 5 will be in the first position. So 1 multiplied by 5 raised 1, because we're dealing with base 5, plus 2 multiplied by 5 raised 0. So I'm using those two because I can't go past 5. The number is 7, so I have to stop at 5. So last time we talked about positions and places and values. So I have the 2 digits. The first one is 2. The next one is 1. So 2, 1. So the number 7 in base 10 is the number 12 in base 5. Recall that we can go back to the original base, which is 10. We know how to convert a different base other than 10 to base 10. So we could do a quick check of our answer. We did this in one of the previous videos. So 2 times 5 raised 0. 1 times 5 raised 1. 2 multiplied by 5 raised 0. 5 raised 0 is 1. So 2 times 1 is 2. 1 times 5 is 5. Add them together, we get 7. So it works out. We have the correct answer. Let's take another easy number, 12, which is in base 10, and we want to convert it to base 7. So I want to go in powers of 12 until I hit, powers of 7, until I hit a number that is less than 12. So 7 raised 0, 7 raised 1, 7 raised 2, 7 raised 3, keep on going. 7 raised 1 is 1, 7 raised 0 is 1, 7 raised 1 is 7, 7 raised 2 is 49. So the number 12 is bigger than 7, but you can't go to the next number because it's 49 and it gets bigger than 7. So this conversion can only have 2 digits, and the digits would be the second place and the first place. So we will have a 2-digit number in base 7. So 12, I know the first number that is less than 12 and a power of 7 is 7. And that leaves me with 5 that is unaccounted for. So I could write 7 as 1 multiplied by 7 raised 1, because we are converting it to base 7, plus 5 multiplied by 7 raised 0. So the first 2 positions. And that would mean I have the 2 digits for base 7. The first one is 5. The second one is 1. So I would end up getting 15. So the number 12 in base 10 will be the number 15 in base 7. We can always verify the answer that you get until you get good amount of practice. So let's start with base 7 and let's see if we can convert it to our regular base 10. So 5 times 7 raised 0, 1 times 7 raised 1. So we will end up having 5. 1 times 7 is 7. Add them together, 12. So base 7, 15 over here is 12 in base 10. So I'm writing this out for you to understand, but you can actually do this mentally if you know the first few powers of any base. For example, first few powers of 5, first few powers of 7, first few powers of 9. Once again, this is only possible, mental stuff is possible for small numbers, just like regular multiplication with base 10. Larger numbers, it'll take some work. We want to convert 13, that is in base 10, to a base 4 number. So I'll start with powers of 4, because this is base 4. And 4 raised 0 is 1, 4 raised 1 is 4, 4 raised 2 is 16, 4 raised 3 is 64, and so on. The base 10 number that we have is 13. So 1 is less than 13, 4 is less than 13, but I can't go past the first position. So the base 4 number can only have 2 digits. So we are going to split it up. We know the first position is going to have a 4, or the second position from the left or from the right. The next one is 1. So the 4 and 1 here comes from the 4 and 1 there. What should we multiply by 4 to get 13? It has to be, or get a number less than 13, it has to be 12. If I account for 12, I'm left with 1. So I'm going to put 1. So the 2 digits in position 1 and 2, position 1 from the right is, 1. Position 2 from the right is 3. So 1 and 3. So the number 13 in base 10 is equal to the number 31 in base 4. With a lot of practice, you should be able to do this in your head. So we can do our usual check just to be sure we have the right answer. 31, we want to convert it to base 10. So 1 times 4 raised 0, 3 times 4 raised 1. 1 times 4 raised 0 is 1. 3 times 4 raised 1 is 12. If I add those, I get 13, and that number is in base 10. So my base 4 number 31 is the base 10 number 13. So things worked out just fine, and our answer is correct. I want to convert the base 10 number 6 to base 2. So since it is base 2, I'm going to write out powers of 2. These are easy, so I'm just going to write them out all the way up to 2 raised. So 2 raised 0 is 1, 2 raised 1 is 2, 2 raised 2 is 4, 2 raised 3 is 8, 2 raised 4 is 16. And as I get closer and closer to 6, I can see 1 is less than 6, 2 is less than 6, 4 is less than 6, but I cannot go past that because 8 is greater than 6. So I will have 3 digits, 4, 2, and 1. 3 digits from the right-hand side, position 1, position 2, and position 3. So we go back and write 6. Using the corresponding powers. So 4, 2, 1. So if I put 1 there, 4 times 1 is 4. 1 times 2 is 2. 0 times 1 is 0. If I add, I'll get 4 plus 2 plus 0, which is 6. So what should the base 2 number be? It's whatever value that you multiplied by. In this case, it is 1, 1, 0. So 6 in base 10 is 1, 1, 0 in base 2. We can verify our answer. We know how to convert base 2 to base 10. 0 multiplied by 10 raised 0. Oh, sorry. 2 raised 0. 1 multiplied by 2 raised 1. 1 multiplied by 2 raised 2. So 0. 2 times 1 is 1. 4 times 1 is, sorry, bad math. 2 times 1 is 2. And if we add those, I get 6. So the base 2 number 110 results in base 10 number 6. So we start by writing our powers of 6. So 6 raised 0, 6 raised 1, 6 raised 2, 6 raised 3, keeps on going. 6 raised 0 is 1. 6 raised 1 is 6. 6 raised 2, 36. 6 raised 4, 216. And it keeps on going. So 1 is less than 37. 6 is less than 37. 36 is less than 37. So we can't go past that. So our base 6 number will have 3 digits. And mind you, all 3 digits must be less than the number 6, because any digit in a base 6 number cannot exceed 5. This is from last time. So I want to split up 37 so that I can write it as a power of 2. Which is 36, a power of 1, which is 6, and a power of 0 for 6, which is 1. So if I put 1 here, naturally 36 times 1 is 36. That would leave me with only 1 value. And what is that 1 value? Or 1. So how do I get 1? So I cannot put 1 here. If I put a 1 there, 6 times 1 is 6, and when I add, I'm not going to get 37. So I will have to put 0. The next one has to be 1. So 1 times 1 is 1. So we will have 1, 0, 1 as the corresponding base 6 number. So I'm going to write powers of 4. So 4 raised 0, 4 raised 1, 4 raised 2, 4 raised 3, because it's easy. 4 raised 0 is 1, 4 raised 1 is 4, 4 raised 2, 16, 4 raised 3, 64. 1 is less than 19, 4 is less than 19, 16 is less than 19. So my final base 4 number can only have 3 digits, and all 3 digits must be less than 4. If you come up with a digit that's bigger than 3, you made a mistake. So how do I split that 19? So 19, going to pick the numbers over here, 16, 4, and 1. So since it's 19, I can put 1 right there. The next question is, should I put 1 or 0 in the next place? Mind you, you can't put negative values. It has to be a positive number. So if I put 1 here, I'll have 4. 16 plus 4 is 20. So that cannot be the correct answer. So it has to be 0. In 19, I have accounted for 16, which leaves me with 3. So I will have 3. So 1, 0, 3, 103. So the base 4 number corresponding to 19 in base 10 is 103. This is something that would work for small numbers. But what do you do if you have a bigger number? You can't do it mentally. This is why you have a calculator or something on the side. You may ask me, well, how do people do this in practice? Well, we have computers, we have calculators and so forth. So I'm going to use this example, which is an easier one, to illustrate the process that we use for larger numbers. So we already recognized that we have to go up to position 2. So 1, 2, and 0, 1, 2 in terms of position. So I'm going to do simple division in base 10. So I'm going to take the number 19, divide by 16. 16 times 1 is 16. That would leave me with 3. So you have 1 and you have 3, and you can't go any further because you can't divide 3 by 16. That is going to become, kind of pointless. So the maximum that you can do is to come up with 1 and 3 in position 2 and position 0, which would naturally mean I have to put a 0 right in the middle. So that number is 103, which is equivalent to what we did earlier, mentally, in a sort of way. So we have 1, we have 3, but I know there has to be 3 digits. So the middle digit has to be 0. Here is a bigger number. Of course, you could do this mentally with practice, but let's do using the approach of long division. We want to convert 87 to base 5. So write out the powers: 5 raised 0, 5 raised 1, 5 raised 2, 5 raised 3, ... So 1, 5, 25, and 75. That would mean 1 is less than 87, 5 is less than 87, 25 is less than 87. So my base 5 number must have 3 digits. Let's go with the division process. Start with 87, pick 25, 25 times 3, 75. Subtract, we will get 12. Take that 12, and naturally the next number will be 5. So 5 times 2 is 10, which will give me 2. And I can't go any further. So what is the answer? Digit in the second position, first position, 0th position. So the number here is 3, 2, 2. So 87 in base 10 is 322 in base 5. Here is an example where I would like to convert 108, which is in base 10, to base 4. So 108 to base 4. So we need powers of 4. Oops. So 4 raised 0 is 1, 4 raised 1 is 4, 4 raised 2, 16, 4 raised 3, 64, 4 raised 4, 256, ... 1 is less than 108, 4 is less than 108, 16 is less than 108, 64 is less than 108, and that is the farthest that I can go to the left. So my base 4 number must have 4 digits. Position 0, starting from the right hand side, position 0, position 1, position 2, and position 3. So we start from the left, which would be position 3, 108, we divide by 64. 64, now we would go with regular base 10 division. 64 times 2 is 128. So I have to put 1 there because the dividend is 108. So 64 times 1 is 64. And I'd like to subtract like we always do, which gives me 44. The next step is to take that 44, which is the remainder, and divide by the next digit value, which is 16. 16 times 2 is 32. Subtract, I will get 12. Still have a remainder. So 12, 4 times 3 is 12. Subtract, get 0. Since I get a remainder of 0, this is slightly different from the previous problem where we didn't have a remainder of 0. Since we have a remainder of 0, this 0 will correspond to the very last digit. So from the left-hand side, 1, 2, 3, and 0. So the number 108 in base 10 would equal to the number 1230 in base 4. So since it is base 3, let's write it out. So 3 raised 0, 3 raised 1, 3 raised 2, 3 raised 3, 3 raised 4, ... 3 raised 0 is 1, 3 raised 1 is 3, 3 raised 2 is 9, 3 raised 3 is 27, 3 raised 4 is 81, 3 raised 5 is 243. So we can go all the way up to 3 raised 4, which is 81. This tells us that the base 3 number has 5 digits. So let's start from the left. 129, we have to divide by 81. 81 times 1 is 81. Because 81 times 2 is 162, and that is going to exceed 129. So if I subtract, I will get 48. So the next step would be to take the 48 and divide by 27. 27 times 1 is 27. I can't do 2 because that would make it 54. 27 times 2 is 54. We can't do that. So 27 times 1, 27. If I subtract, I get 21. Can proceed further. I can keep on going up to 5 divisions because I know I'm going to have 5 digits, or 4 divisions because I know I'm going to have 5 digits. So the next one, I'm going to divide by 9. 9 times 2 is 18. Subtract, I get 3. The next one would be 3, the remainder from the previous step. Divide by 3. 1 gets 3, which gives me 0. So from the left, the base 3 number is 1, 1, 2, 1, 0. So 129 in base 10 would be equal to 11210 in base 3. 25. So we want to convert 428 to base 9. So we'll start with 9 raised 0, 9 raised 1, 9 raised 2, 9 raised 3, 9 raised 4. You can keep on going. So this is not, 1. 9 raised 1 is 9. 9 raised 2 is 81. 9 raised 3 is 729. Keep on going. But we're just going to deal with small or relatively small numbers. So very first step, you have to realize that the maximum value that we can go is up to 81. That would mean our base 9 number can only have 3 digits. So 428 divided by 81. So 81 times 4 is 324, which is less than 428. 81 times 5 is 405, which is also less than 428. So 81 times 5 is 405. Subtract 428 minus 405 is 23. So the next step, I take the remainder, 9 times 2, 18, subtract, I get 5. Mind you, if we have 3 digits, you just have to do 2 divisions. If you go back and look at the previous problem, 4 digits, I have, 5 digits, I divided 4 times and took the remainder for the last one. 4 digits, I divided 3 times and remainder became the last digit. So here the number would be 525. So 428 in base 10 would be equal to 525 in base 9.